What is that?
¿Qué pasa? And. Y. Y. There we go. Angles and parallel lines. This is my and in the middle. Are you going to lead this activity, Ms. Sider? No. Do you want to do the cutting?
Do we want to do it this way?
I don't know. I don't know how else to do it.
Okay. I mean, the other way to do it is to just keep this whole thing in thirds.
No, that's going to be too much, I think.
Yeah, let's do it.
I like it separated in my brain.
Let's make sure we do it so we have enough room for this then. So like have them do it right next to each other.
It's a good idea. I guess.
All right, in front of you have a piece of paper. We're going to actually use this paper today. We're going to make some foldables, so we're going to make two different ones. So your first step is to take your paper and cut it in half. So I like to fold it in half so I get a nice straight cut.
I do not.
Rip it or cut it.
I like to just cut it and guess.
2 pieces. Magic.
2 pieces. This way. Okay. Doesn't have to be perfect. And then you're going to use scissors and actually cut it so it's into 2 pieces.
Yo los he puesto los tiempos ya empiezan.
So cut your piece of paper in half.
Bueno, ya los tiempos ya.
Rápido.
All right.
No bueno.
All right.
Ya le hizo más.
What we need to do here is we are going to trim a little bit off the edge.
La creatividad está la
So eventually we are going to be putting our pages in, but they're a little too big to fit in your notebook. So lay it on your page, don't glue it yet, but lay it on your page and kind of see how much you need to cut off to make it fit right in there, and cut a little bit off of both, okay? So they have to fit in our page, so lay it down, mark how much needs to come off, and cut a little bit extra off.
About 1.5 inches or so. So you're cutting just a little bit off the edge, so that way it fits on the paper. So if you lay it on your notebook, you want it so it fits on. Because it doesn't work that way. My brain doesn't work that way if you're not making it. So it needs to fit.
Okay, so eventually you're going to have 2 halves trimmed down so that they'll fit on your notebook.
Yep, as long as it's good enough. So do both that way. Nope, don't glue it yet. So it's on the page.
Los dos más inteligentes lo sientan son.
Every time I walk by, I just do another step, and I was teasing Chase that he thinks that he just...
Yes, they should be about the same, so you can just line that up on the top. Well, yeah, it's not going to fit yet. We're not there yet. Well, we will be. It's just not there yet. All right.
30 seconds.
Next thing you're going to do is you're going to take each of these and you are going to fold them in half. So you got this, and you got this.
Eso que nosotros siempre nomás. ¿Verdad que sí, Juan? Por eso ya vende otros años. Yo no puedo cambiar lo que viene de... No como que... Lo que viene de los siempre es el yo solo voy.
At this point, you can glue down the back sides so that they flap. And you want to glue them so they're kind of at the top of the page so we have a little bit of space left on the bottom. About 5 or 6 lines, hopefully. So you're going to glue them so that the flap is up. So far all we did was we folded it in half and then we're just gluing the back side down. Yeah, fold it in half. So you should be able to still get to the flaps. I have them so that they flap up, because that's, to me, what makes sense. Alright, about 1 more minute to get to this point, then we're going to move on.
Okay.
¿Sabes qué está así? Fue Morel que lo pintó. No, eso fue Morel. Eso era de Morel, yo me lo di. No, Morel, no Bruce. Ese abrigo que la tiene salada.
Alright. We are then going to make 2 cuts in each. We're going to have 6 flaps total. So on this top flap... Oh, are you making fun of me? Why? We're going to do 2 flaps, so we have 3 total, 2 cuts. So 3 flaps on top. And same thing on the bottom, 3 cuts, just on that top flap. So then we have 3 on the bottom, 3 on the top, 6 total. And then you can, after that, you can put the glue sticks away, you can put the scissors away, and take out the colored pencils. So after that, you can put the glue sticks away. What do you think we're doing? I just make 2 cuts all the way up. Yep.
Hay que pegarlo con esto abajo.
Nicely done.
Yes, sir.
All right. So once you have those in, take out your colored pencils. I'm going to be switching between, I like to use for some reason I use the black colored pencil as my pencil today. But I'm going to use 3 different colors. It just looks really cute. So I'm going to use the black colored pencil still. But I'm going to use black, red, green, and purple. So I'm going to use, glue that in. Blue, black, red, green, and purple are the 4 that I'm going to use. If you want to use 4 other colors, you can. But I'm going to use 4 colored pencils. Okay, ¿qué pasa?
Last place.
Naranja. Naranja es muy feo. So those are the colors I'm using. You just need 4 colors. It doesn't have to be the same 4. You can pick whatever color. If you want to pick orange. If you're like really upset that I didn't use orange, it's okay. All right, about 30 more seconds, and then we're going to get started. Good. 6 bucks.
Todo negro, güey.
You leave it in it.
Ah, no, eso es verde. Verde, azul y morado. Azul y verde no se lo puro. Negro.
Alright, if you ever need to sharpen your colored pencils or your regular pencils, we do have that sharpener in the back. The sharpener in the back here can handle colored pencils, and it can handle regular pencils as well. This one, that's the electronic one. Alright, so we're going to get started. Today we are going to learn about 6 ideas or 6 relationships. Alright, so to start off with, we are going to do vertical angle theorem. Vertical angles theorem.
Before. We learned about that already. Who remembers what is a vertical angle? Or what do you remember about a vertical angle? Look back if you need to. What are vertical angles?
Where are they located from each other?
Across.
Yeah, across. Good.
And what do we know about vertical angles? They're congruent. Very good. So what we're doing here is just adding the theorem. Remember, we talked about that word theorem already when we were looking on proofs.
Theorem is something we could write a proof about.
We can prove that it's true.
Okay, so what we're going to do here is we're going to draw 2 lines like how we have been. And then we're going to draw a transversal that goes through those lines. Remember, transversal means it cuts through the lines. Okay, I'm going to use red and green to be marking my angles today. So if I have this angle here, where is the vertical angle with that one? Like next to, below. Yeah, this one's kind of below with the way mine looks. So this is my vertical angle. So with vertical angles, we aren't necessarily going between the 2. We're just going across in the intersection. And we said that those vertical angles are congruent. So I'm going to write my symbol for congruent. If you want to, you could write like same, or equal if you need to. You could write that whenever we write congruent today, or if you just want to write it once, or if you don't need to write it at all, don't write it. It's up to you. So congruent means that they are the same or equal. So when we see those vertical angles, they're right across from each other in the same intersection. They're the same, they're congruent, they're equal. All right, get your phone out, put that away. I see about 4 phones right now. Yeah, they're across from each other. Yep, so we're not going from here to here. It's just like if they're in one position just across. Yep. All right, next up, we got linear pairs on your next flap. Linear pair. Again, this is one that we know already. We're just rewriting it so we can talk about it in this chapter, put it on our second lesson. So in our linear pair, again, we're going to be dealing with transversals today. So we're going to have 2 lines. And then there's 1 line that cuts through both. So you can make that however you want as long as it goes through both of those lines. So what does linear pair mean? When we see that word linear, it means it makes a line. It makes one straight line together. So if I have this angle here, where would be a linear angle, or another angle that would make a linear pair? Across, next to, at the other place. Yeah, next to. It's either going to be this one or this one. It doesn't matter which one. Okay, so I'm just going to do this one. Are these 2 angles congruent? No. So I'm going to do the 2 arcs here with that red to show that it's different, but those are the 2 angles we're talking about.
So they're not congruent, but what do we know about those 2 angles? The angles that form a linear pair.
What do we know about a line?
To make a line,
Yeah.
what do we know about the measure of a line? It's 180. Yep, 180 degrees.
What do we call those angles that add up to 180? That would be, yeah. When we have a pair, we call them supplementary. And supplementary means that when I add them, it equals 180. So when I add my green and my red, it equals 180. If you don't want to use the plus sign there, you could just actually write the word add and say add to 180. T-O. Okay, so again, we're not going from one intersection to the other intersection. We're just looking right next to each other. They make a straight line. All right, so those 2 are the review. That's ones that we did from we talked about them a little bit last chapter. We really talked about them a lot in chapter 1. Okay, now we're going to move on to our stuff from chapter 3.
So this is what we really were working on yesterday.
So our next one is going to be the corresponding angles postulate. DC. All right, with these postulates and theorems today, on these next couple, what's really important is that we have parallel lines. So what are parallel lines? That go on forever? All lines go on forever. Yeah, they never intersect, so they run side by side forever. So you did it with your hands, Tom, so you just didn't say it. You did this. Yeah. Okay, so when we do corresponding angle postulate, when I draw my lines, I'm going to draw two lines that are parallel, and I'm just going to do two horizontal lines to start off with. Does anyone remember, how do I show to my reader, because I didn't use like a ruler, one's a little crooked. Okay, how do I show to whoever is looking at this that they are parallel? Yeah, we do an arrow or like a triangle on that line. So I'm going to use purple to show that they're parallel. I'm going to do kind of this triangle here and a triangle here. And all that marking means is that, yep, those are indeed parallel, even if they don't look exactly like if it looks like they're a little crooked or they're going to run into each other, they're not. It was meant to be parallel in the perfect world. Okay, then we have our transversal cutting through it. Now this one's a postulate. Does anyone remember what's the difference between a postulate and a theorem? Yeah, a postulate is just something that we accept as true. We can't prove it, but we know it's true. Okay? This is black, this color. Why? Can't prove it. We just know it's black. Something we accept as true. Everyone agreed upon, yep, that's black. Okay? What? Well, yeah, but, okay. If you're not colorblind, this is black. All right. So this postulate is just accepted as true. If we have parallel lines and we have a corresponding angle. So corresponding angle means it's in the same spot but at the other intersection. So if I take this green angle here, which angle is in the same spot down here? In the same position. A, B, C, or D? Literally heard every letter.
I'm hearing more D's.
D's? Mm-hmm. Yeah, so down here, this is in the upper left, so this is going to be in that same spot. It's like we copied and pasted it. That's what I think of. Like if we cut this out and we picked it up and then we pasted it down here, it'd be in that same exact spot. No. No. Can you fill it though? Yeah. What did you ask if I was going to chug it? Yeah. No, I just want it filled. You don't have to empty it. You just put more water in it. All right, and what the corresponding angles postulate says is that those angles that are in the same spot when we have those parallel lines, those angles are going to be congruent. They're going to be the same. They are equal to each other. They're the same. If you want to write same or equal there, you can, like we did here. Okay, so when we see those corresponding angles, we know that they are congruent when we have parallel lines. Three down? 3 to go? Crushing it? All right, next up we have alternate interior angles theorem. Oh, can't see that. Alternate interior angles theorem. So it feels like a lot, but really from yesterday, what's the new word here? Theorem. We already talked about alternate interior. We know alternate means what? Alternate is like opposite, right? Or to change. Interior is inside. A theorem is just something that we can prove. So we're going to talk through the proof a little bit here. We're not actually going to write the proof, but we'll talk about it. Okay, so we're going to start with parallel lines again. This time, what? We're waiting for some people to write this down. Okay, so we're going to do our two parallel lines. This time I'm going to go kind of slanted. Okay, another way to show being parallel other than drawing triangles is you can always just do like another arrow on top of the line. That's going to show that these are parallel. They're running side by side. There's space between them and they'll never touch. So you might see that written down when you read lines. And here we're going to have a transversal going through those angles. This time we want to mark two angles that are alternate interior angles. So interior means they are inside. Alternate means opposite sides of the, not the angle, the opposite sides of, what do we call this line? Transversal, yeah. Good. So I'm going to mark this one first, just for funsies. If you feel good about knowing the alternate interior, you can mark that with the other color. So interior tells us it's going to also be on the inside, but on the other side of the transversal. So I'm going to cross over and then go to the other intersection. All right. Using the last postulate we just said. Our last postulate was the corresponding angles postulate. And the corresponding angles postulate told us if it's in the same position, they're congruent. Okay? So if I go down to this one, which one is the same as this green down here? Is it A, B, C, or D? Yeah, this one here. I'm going to really lightly do that in green just so I can kind of see it myself. But that's not really part of the theorem. That's part of the proof. So I know this green one here and this one are the same because they're corresponding. What do we call this light green one and this red one? Vertical. And verticals are also congruent. So if this is the same as this and this is the same as this, what do we know about all of them? They're all the same. And what property is that that says if this is the same as this and this is the same as this? That's that transitive property. This is the same as this. So we could write a proof. We're not going to today. We might in the future. But today we're just going to say, yep, they're congruent. Ugh, that was a bad congruent sign. There we go. So we're really looking at that green and that red. Two more. Easy peasy. And then we have one example we're going to do, and then you have some practice. Alright, next up, we did alternate interior angle theorem. So next is going to be the consecutive interior angle theorem. Consecutive interior angle theorem. So what's the only difference between these two? Yeah, there's supposed to be an S there. Alternate consecutive interior angles. Okay? Yeah, this one's consecutive. So what does consecutive mean? Close. Consecutive means like back to back. Like if you have two consecutive wins, that means you won back to back. It's like the same. Okay, same side. So when we look at this one, again, we're going to start with parallel lines. This time I'm going to draw my parallel lines this way. Switching it up, guys. When you see parallel lines, you might see those arrows. Sometimes you'll see more than one arrow. Sometimes you'll see a double arrow. And you'll usually see that double arrow if there's like 4 or 5 lines. You might see that double arrow because maybe these two are parallel, but then now these two are parallel, but we want to show that they're not parallel to each other. These ones are parallel. Okay, and then we have that transversal cutting through it. So we're dealing with the interior, so that's the inside. So I'm in between these two lines. Doesn't matter which one I start with to show this. I'm going to just show this one here. So I want another inside angle that's on the same side as the transversal. So our transversal is this line going across. This one's above. So I need the other above one, which is this one here. Do those angles look the same? No. So let's use that double arc there because we know they're probably not going to be the same. Just by the way it looks in my picture. It might look a little different in yours. So let's think. Think. What angle over here do I know is the same as this red angle? The one right, this one? Yeah, this one's the same because what are those two angles? They're congruent because what relationship do they have? Yeah, these two are alternate interior. So I know that these are the same. And then what do I know about this one and this green one here? They're not the same, and they make a straight line here together. And when they make a straight line, we know that they add up to 180. So if these two add up to 180, and these two are the same, what do we know about these two? These two are the same, but what do we know about these two? Yeah, they add up to 180. They're supplementary. So I know when I take my red angle plus my green angle, it will make 180 degrees. Alright, last one for today. Alternate exterior angles. Yeah. Alternate exterior angles theorem. So again, this is another one that we can prove using our properties or using our other theorems that we have. We could write like a 4-step proof. We won't today. But maybe for like our warm-up tomorrow we will. Maybe. Just kidding. Miss Sider already wrote the warm-up for tomorrow. It's not a proof. Alright. No. ¿Listos? Alright. So we have our two that are parallel, our two lines. I'm going to go with like some vertical lines here because I haven't really done those. And then you can choose how you want to mark them as parallel. So if you want to use a little arrow, if you want to use 2 arrows, you could. Or if you want to do the triangles, you could do the triangles. I'm going to do the triangles because that's really hard for me, so I'm practicing it. I hate the triangles. Feels like it should be easy, but for some reason the triangles just always screw me up. Like an H. Cut your transversal through. And then we're going to mark 2 angles that are alternate exterior. So what does that word exterior tell us? Outside. So if I have this one here, this is on the outside. I need another outside angle, but it has to be across the transversal. So since this one's above my transversal, I'm going to go below, but I'm going to go to the other intersection. So over here on the other outside. Okay, we know that alternate exterior angles, do you think that they are congruent or supplementary? Congruent. Alright, there is a practice in Schoology. The first 2 problems in Schoology in the week 8 are vocabulary. After that, it goes by really quick. So it's just like naming, are they congruent, are they supplementary? So use your notes when you do the practice. Okay, practice is on Schoology. It's due tomorrow, so try it once. Remember, you can try it more than once, so try it tonight. See if you need help on it. You can get help on it tomorrow if you need it. Have a good day.
¿Te dejan tocar allá?
¿Eh?
Thank you.
Right away, I'm just going to take 15 bits. I don't have anything to sit in.
Is that when you're there?
It almost. And we'll do that.
Yeah, I guess.
Okay. And then